Hello, I'm Ross, and today I'm going to show you how you can safely cache dynamic content and achieve very fast response times from an API with entity tags. When you create a web app, a common performance optimization is to save many of the files that are required to run your application on users' devices, so the next time they load that page, it will load faster. You can see all of these in your browser cache, and for every response that's sent from your application, you can set headers in the response that tell the browser how to cache the requests in various ways, which we're going to get into in the tutorial. Many assets like JavaScript and CSS can be cached for a really long time because they have unique hash file names that are generated by a lot of modern build tools. For example, Vite will take all of the CSS and JS and generate different file names for them when you run Vite build. These assets are requested indirectly by the client, so people aren't navigating directly to these hashed URLs, but they're navigating to an HTML page that has all of these assets linked. So you can safely serve these assets from the cache because you'll always make sure that they have the hashed file name. Every time one of these files is updated, a new hash will be generated for the file using the content in the file, and the client will always make the request to the correct newest asset since the link is provided directly in the HTML and they're not navigating to that on their own. These assets are often all output during the build process to an immutable directory, and that makes it easy for an API to say any path that starts with immutable will be served with these immutable cache headers. And if you want to set those headers, it would look something like this. So they're public, immutable, and then they have a max age of 1 year. So all of these assets are cached on your device for up to a year. One response that can generally not have a hash URL is the HTML response. Users need to be able to navigate to the same URL and always receive the most up-to-date HTML page. You wouldn't want to have to send a new link to your users every time you updated your website. So this response can still be sped up, although it can't be cached indefinitely. You can use something called entity tags or ETags. And ETags allow you to check if the file has been modified since the last time it was requested. And if it hasn't been modified, you can just send a small response back from your server that says, hey, this hasn't changed, instead of sending the entire asset again. So I'll be going through a tutorial how to implement ETags and speed up your HTML responses. I'm going to be using DOM to show you how to do this, but you can use any server-side JavaScript framework that supports setting custom headers on a response. So I've run the npm create DOM at latest to get this template that I'm going to use, and the final example can be found in this repository as well, and I'll link to this blog post in the description if you'd like to follow along. So here's a simple example of sending an HTML response without an ETag. DOM lets you import your HTML as a string, and you can see in our request handler, we're just returning that HTML directly with our content type header of text HTML. So currently this response requires the response.body to be sent over the network every time this page is requested. And the user will always have to download the entire file every single time. So we can use ETags to speed this up. The first step to utilizing ETags is to create a hash with the content that you're sending back. And we'll use this to check if the content has changed. Since ETags are generated on every request, it's important to choose an efficient method to create a unique, consistent hash. The hash must produce the same output given the same input in order to understand if the content has changed since the last time the hash was created. So if you wanted to use like the current time, that's not going to work unless you're generating it at build time. Since ETags are generated on every request, if you use the current time, it would always change. So it has to have the same output given the same input to generate these dynamic ETags. I did some research and looked up how different frameworks generate these ETags. I've linked to the code in my blog post where these ETags are created. All these methods seem to work pretty well in widespread production use. I'll just be going through a few different examples here, and and you can choose the one that looks the best to you. Serve is a really popular package to serve static assets in Node.js, and they use a combination of the file size and the last modified time. So you can see here they're adding in stats.size and stats.modifiedTime.getTime, and they're using just a combination of those two things to create the ETag, and this works for static assets, but not for dynamic assets, since you may be generating your HTML on the fly, and in that case, you don't have a file that you're reading from. But if you do have a file system, this can work really well to create your ETags. Next.js and Astra both use the same FNV-1A algorithm from this FNV Plus project. Looks like they have actually the exact same code in both of their code bases, so give this a look. SvelteKit uses a JavaScript implementation of the DJB2 algorithm, which I'm going to be using in this example. It seemed like the simplest one to me. I adapted it to use TypeScript, and you can see that in this gist here if you'd like to pull it to use for yourself. Hono and the actual ETag package on NPM both use the SHA1 algorithm. Hono uses it via the Web Crypto API, and the ETag package uses it via the Node Crypto API. So that's another well-tested algorithm you can use to create these ETags. I don't think it really matters very much which algorithm you choose, but as I said before, you want to make sure that given the same input, you receive the same output for a hash, and you want to make sure that these can be generated quickly if you're doing these on every request. So the first thing we're going to do is we're going to create an ETag using our HTML string and send it to the client in a response header along with the HTML. So I'm going to pull that code for the DJB2 algorithm, and I'll paste that into my function here so I can create a hash with the HTML. So let's add that in here. We're going to create the ETag with that DJB2 algorithm, and so ETags need to be surrounded in double quotes. And we'll just use that DJB2 and we'll pass in our HTML to create the ETag. So you can see what this looks like. I'll just log it here. And we'll navigate to our page. And you can see we've got our generated hash there, which we can use for our ETag. So the next thing we need to do is just to send this ETag within the headers of our response. So we'll say for our ETag header, we'll send our ETag. And now we'll take a look at this in our development tools. And we can find our ETag. If we look at the HTML response, this is what we're sending. And you can see in our response headers, we're getting that ETag here. Another thing to notice is when the browser sees that an ETag has been sent, whenever we refresh that page again, it will automatically send this if none match header back to our server in a request header with the same ETag. So we're going to use this to check to see if this hash matches again what the server's sending, and if it does, we'll know the content hasn't changed since the last time the client got this response, and we can send back a not modified response with just that message that says, hey, this HTML hasn't changed at all since last time, just reuse what you already have. So you can see what that looks like here. We're going to create a not modified Boolean, and it will check if our ETag is the same as the if none match request header. And then you can see here, if it's not modified, instead of sending our HTML back, we're just going to send null because we don't need to send the entire content back again. The client will just reuse what it already has. and we're going to change the status to 304 instead of our 200 status code. Okay, so we've got that set up here. Now let's check out how that looks in our development tools. So now when we load up our development tools, I've disabled our cache here, and you can see what this will look like if we didn't send the ETag back. You can see our HTML response is 889 bytes. So let's enable our cache, and you can see how the ETag works here. So we'll refresh the page, and you can see that instead of getting a 200 response back, we're getting our 304 response back, and instead of the 800 some bytes, we're only getting 186 bytes back in that response now. So you can see in this example, it doesn't have much of an effect, but if you had a really large HTML page, this can dramatically speed up the response time for your website, because you'll only be sending a really small response back instead of the entire HTML page again. I hope this provides some insight on how you can speed up your web application with different caching techniques for large HTML pages, or if you're on a slow connection, this technique can really help speed up the loading time of your website. Thanks for watching. Let me know if you like this video by hitting the thumbs up button, or subscribe if you'd like to see more content like this in the future. Have a great day.